today our topic of discussion will be covalent bonding. So what is actually covalent bonding? So covalent bonding is basically a bond formed by sharing of electrons, by sharing of electrons between two non-metals, between two non-metals. Okay. So it can either, it can either be formed between atoms of same element, okay, of same element, or can be formed between atoms of different elements, okay, can be formed between uh, atoms of different elements, okay. Okay, so basically, first of all, uh, covalent bonding can be of different types. Like covalent bonding is basically of two types. Either it can exist as simple molecular structure, and most of the non-metals they are having covalent bonding in simple molecular structure. While there are some elements which possess giant molecular structure, giant molecular structure. There are only three giant molecular structures that are included in your O-level syllabus, and that is first of all diamond, the other is basically graphite, and the third one is silica. Silica, which is also called as sand, and its formula is SiO2. And simple molecular structure is basically adopted by most of the elements like chlorine, like bromine, like hydrogen, like carbon dioxide, like water. So they all are having simple molecular structure between them. Okay, so let's move further regarding, okay, so let's move further regarding uh, covalent bonds. First of all, you can say covalent bonds can be of three types. Like they can be single covalently bonded, and they can be double covalently bonded, or they can be triple covalently bonded. Okay. So now, first of all, let's discuss about single covalently bonded elements. Covalently bonded elements. Single covalently bonded elements are those which are having single covalent bond. Okay, they are having single covalent bond among them. single covalent bond. Or you can say the one which are sharing a pair of electron, a pair of electron. Now let's see some of the examples related to that. For example, we have hydrogen. Hydrogen has how many electrons in its outermost shell? So it has only one electron in its outermost shell, and it needs to complete only one more electron as it wants to develop its duplet. Okay, as it wants to complete its duplet. So it needs only one electron. So it is going to make a bond with another hydrogen like this. I'm showing the electron of this atom with dot. So I'm showing atom electron of this atom with cross. Okay. So you can see this is basically a single covalent bond formation occurs between hydrogen. And one important thing, as you can see, that they are basically sharing a pair of electron. Okay. So now let's move further and take some more examples related to that. The one which is oxygen. Oxygen, okay. So let's take the example of oxygen. Oxygen is basically O816. So it has 2, 6. How many electron it has in its outermost shell? So it has 6 electrons. So it needs to complete two more electron. It needs two more electron to complete its octet. So what happens, as we know that oxygen is basically having 6 electron in its outermost shell, okay, and it needs to complete two more electrons. So it is going to make a bond with another oxygen like this, okay. And what happens here? It is going to share two electrons. So you can see that this basically represents double covalent bond. This represents double covalent bond as it is sharing, two pair of electrons, two pair of electrons. Okay. Okay, so let's take another example of carbon dioxide. Carbon dioxide, it is, first of all, oxygen is been represented as O double bond O, like this, okay? So carbon dioxide, again, oxygen, carbon has, first of all, let's discuss about carbon. Carbon is C612, it is 2, 4. So it needs 4 electrons to complete its outermost shell. So carbon is going to make two double covalent bond with oxygen like this. This is oxygen and this is basically carbon. This is another oxygen. This is carbon. This is oxygen. Oxygen we know has 6 electron in its outermost shell. Okay. So like this, and we know that this carbon, this oxygen, first of all, this oxygen has again 6 electrons in its outermost shell. And this carbon has how many electrons? It has 4 electrons in its outermost shell. So 2 will come here and 2 will come here. So you can see that there is a double covalent bond that is developed with carbon and oxygen on both of the sides like this. Okay. So now let's move further and let's take an example of, you can say, triple covalent bond. Let's take the example of triple covalent bond. Triple covalent bond. Now, what happens? You know, like nitrogen, N2. So nitrogen is basically N, uh, it has how many electrons? N7 14. So it has 5 electrons in its outermost shell. Now it needs to complete 3 more electrons in its outermost shell. So it is going to form a triple covalent bond with another nitrogen like this. So it would come here, 3 electrons from each side. Okay, 2 would be remaining here and 2 electrons would be remaining here. So now what happens? You can see that 8 electrons have been fulfilled by each nitrogen atom. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now let's move further and let's take some more example like water. Okay. So in water, what happens? Like oxygen has, we know it's OH16, so oxygen has uh, 6 electrons in its outermost shell. As oxygen has 6 electrons in its outermost shell, so it needs to form 2 more electrons. Okay, it needs to have 2 more electrons, so it is going to make a single covalent bond with 2 hydrogen atoms. This is oxygen. Okay, so this is basically represents its electrons. 2 electrons come here, 2 electrons come here, 1 electron come here. So you can see now it is going to make a bond with other hydrogen like this. Hydrogen is sharing its electron here, okay, and this oxygen is basically has shared 1 electron with another hydrogen here, and cross comes here. So now you can see 2 electrons in each hydrogen has been fulfilled, and this hydrogen has also been fulfilled, and for oxygen 8 electron in its outermost shell has been fulfilled. These 2 electrons pairs which are on each sides, they are basically called as lone pair of electrons. Lone pair of electrons, and their structure would be represented as O, this hydrogen, with 2 lone pairs that would come on each side like this. Okay. So let's move further and let's take some more examples which are related to, you can say, methane. Let's discuss about methane. Methane, carbon has, we know it's C612. So carbon has 4 electrons in its outermost shell. So it is going to make 4 bonds with each hydrogen like this. Okay, it is going to make 4 bonds with hydrogen atoms. This is carbon. So 1 electrons come here like this, like this, like this. Okay, you can now see that all the outermost shell of carbon is now fulfilled. Now it has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So its octet is basically completed and duplet of hydrogen is also completed. Now let's discuss one more structure which is of ethene. Okay, this is ethene. Now you can see that there are 2 carbons and 4 hydrogen. So 1 carbon is basically, okay, there is a bond that is developed between 2 carbons like this, and 2 hydrogen would come on each side like this, like this. Okay, so it comes like this. And now what happens if we are going to draw, for example, their electrons? So let's change the color of the pens. So that would be like this, dot and cross, dot and cross. And now this carbon has shared, as you can see, 2 electrons here. There are 2 more electrons of this carbon that would come here like this. okay, and this in the same way it is having, like, it has shared two electrons, but it has total, we know it has four electrons, so two would come here, and you can see a double bond that is established between two carbons and a single bond with two hydrogen atoms that is formed on each side. So their structure becomes like this: double bond carbon, and hydrogen would come here, hydrogen would come here, and this hydrogen would come here, and this hydrogen would come here. Okay. So these are all the examples that are basically related with simple molecular structure. Up till now, we have discussed related to simple molecular structure, and let's now discuss the properties of uh, of uh, simple molecular structure, simple molecular structure, structure, in which you can say a covalent bond is present. Okay, so first of all, there is a property that most of the covalent compound, they have simple molecular structure, so they have low melting point and boiling point, a very important property. Okay, like in the paper they are going to ask you that why they have low melting point and boiling point, or like this kind of questions, so you have to answer them because of because of weak either intermolecular force or van der Waal force. Van der Waal force. You can write any of the answer. That why they have low melting end point, because of weak intermolecular force of attraction. For now, what is basically intermolecular force of attraction? Like for example, we have chlorine, Cl2. You know that chlorine has 7 electrons in its outermost shell, as it belongs from group 7. So it is going to make a bond with another chlorine like this, and so it's would become this, like this. Now, this force of attraction, first of all, this force of attraction is basically called to be as, that is called to be as, you can say, intramolecular force of attraction. That is intramolecular force of attraction, force of attraction. So this force of attraction is, you can say, quite strong, quite strong. That is not weak. But we are saying that they have low melting and boiling point because of weak intermolecular force of attraction. So now what is weak intermolecular force of attraction? This, remember, this covalent bond is intramolecular force of attraction. Okay. Now, so what is intermolecular? So this is Cl2 molecule. This has been attracted with another Cl2 molecule, and there's also attracted with another Cl2 molecule. This force of attraction that is present between molecules holding them together, that is basically called as intermolecular force of attraction. Intermolecular force of attraction, and that is weak traction. Okay, and we also call it as van der Waal force. Van der Waal force. So this force is basically weak in simple molecular structure, while on the other hand, intramolecular force is quite strong. I hope this point is clear to everyone. So let's move further. We have another property, which is They dissolves in organic solvent, that they dissolves in organic solvent and insoluble in water. Like we can take an example. We know that ionic compound, they are basically soluble in water, okay, because of the force of attraction that had developed between cations and anions. And now they are insoluble in water, uh, like for example, oil, which is an organic solvent that is basically dissolved in dichloromethane. Dichloromethane. So this is basically the second property. Now let's move further towards the third property, that they are not a conductor of electricity. Conductor of electricity. And the reason basically is quite simple, because they don't have free moving electrons. So they are not a conductor of electricity in any state. Either that would be gas, that would be liquid, or that would be solid. So they are basically not a conductor of electricity in any state, and the reason is quite simple, that they don't have free moving ions or electrons. So the reason seems to be quite simple. So this is whole about the video of simple molecular structure. I hope it's clear to everyone. Kindly please do like and subscribe my channel. And if you have any question regarding them, then please mention in the comment box. Thank you so much. Allah Hafiz.